Hi everyone, welcome to the Underwater Sensor Networking Lab. Today I'm going to go over some of the basic applications, a broad overview of what we've done in the past and some of our future works, and give you a little understanding of some of the applications to get a better understanding of what underwater really is. Enjoy! So, why underwater? What is the point of us studying this broad range of environments? Well, to start, 70% of the Earth is covered in water. That alone opens up a broad range of applications that gives us range for us to study, measure, and test. So based on this broad range of applications, there are many challenges that we need to face, namely being energy usage, transmission speeds, and dealing with the harsh environment that is underwater. And what energy usage really means is we're placing these different pieces of technology in an underwater environment that we want to be able to be self-reliant for a long period of time. So that means they need to use a minimal amount of energy per use. So that's our first challenge. The second one being transmission speeds. And what that really comes down to is RF waves, which are normally used in wireless networks above water, do not transmit more than a few meters in an underwater environment. So in order to replace this, we have to use acoustic sound waves. And in doing so, our transmission speeds are cut by a large amount. To be exact, they're cut down to roughly 1,500 meters per second compared to RF waves, which travel at roughly 300 million meters per second. So there's a very large jump in speed from that alone. And finally, we're looking at the harsh environment. And what that really means is anything from current and mobility of the technology that we place in the water, human interaction or destruction, and just different external environment factors. So maybe salt or aquatic life and other forms that could cause issues among our data communication and overall application usage. So that kind of leads us into what kind of applications are we going to be using in this? And I'll get into that in a moment. Our lab covers smart ocean technology. And what this encompasses is a large range of applications that can be applied in an underwater setting. So here's a few ideas to give you a better understanding of what that really means. So these examples include monitoring pollution or underwater oil drilling, to early prediction of a phenomena like tsunamis or red tide, as well as other applications like autonomous underwater vehicles for searching or discovery, which could be in the form of retrieving data in an area where humans couldn't easily go to. Alongside this are marine life tracking or surveillance, and different types of defense applications. So with this short but hopefully helpful idea of different applications that you see in an underwater environment, there are a broad range of different departments that need to be filtered into the smart ocean technology and into our lab in general. Anything from computer science to electrical engineering to biology in general, and of course the list goes on. And the reason for this is there's so many different components that are needed in order for this lab to be functional. We need to look at the energy point of view. How can we harvest this energy? How can we move this data from one point to another? And how can we construct all of these different devices that we're placing in the water? These are just a few examples, but of course, it's to help you understand that smart ocean technology is not a very simple idea. It's a very broad range of different applications, different departments that have to come together in order to complete this task. Now that you have a better understanding of why our lab is in place, let me tell you about how far we have come since the original start in 2006. The Underwater Sensor Network Lab originally consisted of a seed fund from different departments across UConn's campus, with a total budget of $42,750. Additionally, there were 12 affiliated faculty and 5 graduate students, with a total of 1 paper published in the field. 7 years later, and our achievements have exponentially grown, with our funding accumulating over $13 million from various programs like NSF, Naval Research, and PCASE. Our personnel has grown to over 30 affiliated faculty and 40 graduate or postdoctorate students. Additionally, our publications jumped to more than 100 papers published that have over 3,000 citations combined. So what are some of the major achievements we've completed over the past few years? Well, the first one being Aquasim, which is an underwater simulator which runs on top of NS2. The purpose of the simulator is to test our different protocols in a theory-based controlled environment. Next, we have Aqualab, which is a small water tank in our lab for sending and receiving data through controlled underwater channels. Last, we have AquaTune and OceanTune, which are both real-world testbeds of different magnitudes. The first of these testbeds being AquaTune, which was completed at Mansfield Hollow Lake. Here, we were able to run different experiments from nodes deployed on kayaks throughout the lake. The second testbed being OceanTune, which is a collaboration of sea testbeds with other universities. UConn's deployment site is Long Island Sound. Currently, this is our largest project, which receives frequent updates and deployments to improve upon our research. So that brings us to the end of our Underwater Sensor Network Lab overview. But before you go, here are a few photos taken from our lab and testbed deployment. Thanks for watching!